Hello Year 6, welcome to your maths video for Monday. Hope you've all had a lovely weekend. We are carrying on, we're carrying on in the same book today, in the Workout Year 6 book, and we are doing page 33 today. So you should have done page 32 on Friday. Carrying on with 2D and 3D shapes today. Okay. So question 1 then says, in each question, shape A has been enlarged. Write down the scale factor that it has been enlarged by. So we did some enlarging by scale factors on Friday on these questions. Okay, so when we enlarged this shape by scale factor 2, we multiplied it by 2, didn't we? We multiplied each side by 2. Okay, so if we need to figure out what it's been enlarged by, we're going to have to figure out what it's been multiplied by. So have a look at the shape that's got A in and count one of the sides. I would just focus on one of the sides for now. So I'm going to focus on the right hand side, and the right hand side in shape A has got 1, 2, 3 squares. Now I'm going to have a look how many is in the bigger shape, and then I can figure out what it's been multiplied by. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I need to do 9 divided by 3, which is 3. Okay, I'm just going to check another side just to check I am right. So the left hand side then, 1 in the shape A, 1, 2, 3 in the bigger shape. So that's been multiplied by 3 as well. Okay, so that one then, A has been enlarged by scale factor 3. Yeah, you have a go at the next one. So if I was you, I'd just focus on one side, check that, and then have a go and check it on another side. Okay, question 2 then says answer these word problems. So it says a rectangle has a width of 4 centimetres and an area of 28 centimetres. It is increased by a scale factor of 8. What is its new length? So I've drawn a rectangle here so that you can see it. So we know that the width is 4. We don't know the length, but we know the area is 28 centimetres. Okay. Before we even think about enlarging it by scale factor 8 and the new length, we've got to figure out what the original length was because we've only been given the width. So to figure out this then, we haven't done area for a while, but you might remember that to do area, to calculate area, we multiply the width by the length. Okay, so to figure out this one then, we need to do 28 divided by 4. If we do the area divided by the width, that will give us the length. Okay, so 28 divided by 4 is 7. Okay, so I'm going to write that in. That's 7 centimetres, so I don't forget. Okay, and now we can carry on and figure out what the rest of the question is. So it says it is increased by a scale factor of 8. What is its new length? And we know that when we increase by a scale factor of 8, that we multiply by 8. Okay, so you just need to multiply that length by 8. On B then, it says a circle has a radius of 16 metres after being increased by a scale factor of 8. What was the original diameter of the circle? Now, I've drawn on here, again, a little reminder for you. So if you remember from the work you did the other day, the circumference of a circle is all the way round, the diameter is all the way across, and the radius is halfway. Okay, so let's have a look at the question. A circle has a radius of 16 metres after being increased by a scale factor of 8. What was the original diameter? So before we can work out the original diameter, we need to work out the original radius. Okay, so you need to do 16 divided by 8, and that will give you the original radius. But we want the original diameter. So once you've worked out 16 divided by 8 and you've got the radius, you then need to multiply it by 2, and that will give you the original diameter. Okay? Question 3 then, it says in each of the boxes below, draw the shape described above it. Now, you're only really going to be able to do this one if you've got a ruler at home, okay? Because you've got to do a little bit of measuring and measure out some centimetres. So if you've got a ruler, great, have a good go. If you haven't got a ruler, there are some on here that are asking you to draw some angles. And I did drop you all off in my math set a protractor. when I dropped your pack off. So you need to find this and then have a good go at drawing the angles, okay? Which I will go over in a minute. So the first one says an equilateral triangle with sides of 5 centimetres. Now, equilateral, think about the word equal. It means that all the sides are the same. All sides are exactly equal, and all sides have got to be 5 centimetres. So you've got to try your best to be really, really accurate. Draw a line at the bottom that's 5 centimetres, then one that's 5 centimetres that way, 5 centimetres that way, and make sure it all joins up. Okay? The next one then says a right angled triangle with sides of 3 centimetres, 4 centimetres and 5 centimetres, and one angle of 49 degrees. Okay, so a right angle then is 90 degrees. It's always 90 degrees, and 90 degrees is like this. It's a perfect corner. Okay, like the corner of a piece of paper, like the corner of a piece of card. Okay, so you know it's always 90 degrees, but one of your angles there has got to be 49 degrees, and you're going to have to use your protractor to help you draw an angle that's 49 degrees. Now, to draw an angle, you need to draw a dot on your piece of paper. So draw a dot down the bottom somewhere in that box, okay? And then with your protractor, you need to make sure that that middle bit there, where, sorry, it's not very clear, where the little T is perfectly on that dot. And I'll do it on my paper and show you. Okay, if it's not perfectly on that dot, then your angle won't be accurate. Okay, so like that there, got to make sure it's perfectly, sorry, mine's not perfect, it's moved slightly, make sure it's straight. So it's perfectly on like that, okay? So you can see there in the middle, my dot is on the centre, okay? Then you need to go to the side, whichever side you want, it's up to you, and find 49. So it depends which side you're going, but you always need to find 0. I'll just move my finger out of the way. Oh, hang on a second. Fold this down so I can hold it. So from this side, where am I? This side, the 0's on the outside. Okay, so I can follow it round. It's probably easier to go this way, if I'm honest, where the 0's on the outside, because then you can count up on the lines. If you go this side, that's fine, but you need to remember that the 0's on the inside. So you're not using these outside numbers, you're using the inside ones, okay? So on this side then, you need to go round to where it says 40. Halfway between 40 and 50 would be 45, and then count up to where 49 would be. So I'll just do it on my piece of paper and then I will show you. So count round 40, 45, 49 would be about there. Okay, so about there. Okay, then you can take off your protractor and join it up to your dot. Hang on a second, draw a line along the bottom, like that, and then that angle there would be 49 degrees. Okay? So on the next one then, it says a parallelogram with a height of 3 centimetres, a width of 4, and angles of 60 degrees and 120 degrees. So you've got 2 angles to draw on this one. And remember, a parallelogram is just a shape that has got 2 sets of parallel lines. I haven't got to, oh, I'll use my protractor to draw you an example of a parallelogram. So a parallelogram might be like this. So it's got to have 2 sets of parallel lines. Remember, parallel means that the lines will never meet. Okay, so this one and this one are parallel. Lines on, and then this one and this one are parallel. Yeah? So they're, sorry, where am I? They're parallel, that way. This one and this one are parallel, and then the top and the bottom one are parallel. Okay, so that one is quite a challenge to make sure you get the 60 degrees and the 120 degrees in there. but just have a good go. You might want to do it on a piece of paper first. You might want to do it on a piece of paper, figure it out, and then stick it on if you want to. But it's up to you. Okay, so that one is quite a challenge. Just try your best. Okay, so that's all the maths that we're doing for today, only the one page. So if you finish early, then make sure you log on to Timetable Rockstars. There is a battle on at the moment, 6A versus 6B versus 6C. So I wonder who will win. Hopefully it'll be 6A. Okay, so I'll see you all tomorrow. Make sure you email me with some pictures of your work for today. I love seeing your maths and what you get up to. See you soon.